composing sine and inverse sine functions. So we want to be able to evaluate expressions involving composition of sine and inverse sine. So let's consider the best case scenario. And this requires us to recall a little bit about composing inverse functions. So typically when we compose inverse functions, the input and the output match, because we can kind of think of sine, like in this first one here, we have sine inverse of sine of x. So sine acts on x to make a sine value, but then sine inverse says I take that sine value and I'm going to just turn it back into that original angle. So this only works though, we know that sine inverse can only give outputs in between negative pi over 2 and pi over 2. And so for these x's to match, right, so for this whole thing to just equal the input, that only happens when x belongs to the interval, so that's what this little symbol means. So x is in the interval negative pi over 2 to pi over 2. So normally we say this can happen when x is in the domain of this first inside function. Well, the domain of sine, we say, well, that's just all real numbers, so why are we having a problem? It's because sine inverse here is limiting us, right? Its outputs can only be between negative pi over 2 and pi over 2. So if I want these to match, right, if I want these to be exactly the same, so if I'm, say, given this sine inverse of sine of x, and I say, well, what's that equal to? If I want it to just be equal to that input angle, that only happens if the angle is in that restricted domain for sine, right? It's not one-to-one, we had to restrict the domain. So if the angle is in that restricted domain, then that makes it easy. Are there any other options? Yes, because I know that the domain of sine is actually all real numbers. So if this x going in here is not in negative pi over 2 to pi over 2, I can still find the answer with some extra work. It's not going to be equal to this x, but I can still find it. So what about the other way around? What if I have sine inverse of x? When does this whole thing just equal the input? And again, that's just saying sine inverse is taking a sine value and giving me an angle, and then I take sine of that angle and just get me out that value again. So when does that happen? Well, sine inverse only acts on things between negative 1 and 1, and then sine only has outputs between negative 1 and 1. And so in this case, x has to be a part of the interval, or the set of numbers, negative 1 to 1. And if not, there's no more extra work that can happen. It's just going to be undefined. So we'll get used to this idea, but it's nice to just have it kind of in one place. All right, so let's look at sine inverse. Let's look at this example. Evaluate each expression or state that it is undefined. Do this without the use of a calculator. So let's start with A here. Sine inverse of sine of pi over 4. So which case is that? That means sine inverse is the outside function in the composition and sine is the inside. So that's this first piece here. So let's kind of remember what that says. So it says, the input here is pi over 4. And it says, well, this whole thing can just be equal to the input if x is in between negative pi over 2 to pi over 2. Well, pi over 4 certainly is. So this is just equal to pi over 4. Check. Okay. What about part B? Sine inverse of sine of negative pi over 8. Well, this is still this kind of case 1 here where sine inverse is on the outside and negative pi over 8 is in the interval negative pi over 2 to pi over 2. So this whole thing is just equal to negative pi over 8. And it's because these are inverse functions, right? They kind of undo each other to leave the input just equaling the output. Again, it's because I have this kind of best case scenario where my input angle is between negative pi over 2 and pi over 2, and sine inverse is allowed to have that as an output. It's in the range. All right, let's look at C and D, which cover the case where sine is the outside function. So sine inverse takes a sine value and spits out an angle. So I'll see, okay, that's what I have on the inside here. Sine inverse takes some sine value and spits out an angle. But is 2 ever a sine value? It's not, because sine values can only range between negative 1 and 1. And the domain of sine inverse is limited to negative 1 to 1. And so we said, if this input value x is not in this interval, then it's undefined. So we're saying if x is not in there, it's undefined. So this is just is undefined. what about sine inverse of 2/3? Well, does 2/3 live inside the interval -1 to 1? Yes, it is greater than -1, but less than 1. Okay, so then that means this whole expression is just equal to 2/3. All right. So let's look at one that requires those extra steps or extra work, which is up here in case 1. So case 1, case 2. So what about case 1 where we need more work? So evaluate the expression or state it as undefined. Do this without the use of a calculator. So sometimes we get lucky and we have the angle inside we can find easily on the unit circle. So if that is the case, then we can kind of go about that. So, and the way that we're going to do that is just start on the inside. So first, just find the value of sine of 7 pi over 6. So I'm going to draw a little unit circle over here. 7 pi over 6 is right here. The coordinates at that point are -√3/2, comma, -1/2. And so the sine value is the y coordinate there. So sine of 7 pi over 6 is equal to -1/2. So what I can do is just say that this entire starting expression is equal to sine inverse of, and instead of sine of 7 pi over 6, I know that its value is -1/2. So I'm going to replace that whole thing with -1/2. So all I've done so far is say sine of 7 pi over 6 is equal to -1/2 as I found on the unit circle. And so I'm replacing sine of 7 pi over 6 with the value -1/2. And so now I do the second part of the problem, which is, what is sine inverse of -1/2? Well, remember what that is asking me. That is asking me for the angle in between -pi/2 and pi/2, where the sine value is equal to -1/2. Okay, well, so let's just find where that lives. That's -pi/2 to pi/2. And so where is the sine value going to be -1/2? Well, it's where the y coordinate is also -1/2. And so that's really just this nice reflection happening over here. Okay, and so when I see that, I go, oh, great. Over here, right, whatever angle this is, we can get to that in a second. This just is √3/2, comma, -1/2. Okay, so now that I have sine inverse of -1/2, because this is sine inverse, right, what is this saying? This is saying find an angle, right, where the sine value is -1/2, but you can only look in between -pi/2 and pi/2. And I go, oh, I found one. Okay, and so what is that angle going to be? Well, that angle is starting at the positive x-axis. Remember, how can I get there? Well, I can't get there on using the other part. I have to go down in the negative direction to get to -pi/6. All right, let's use one where it's not on the unit circle. Makes it a little trickier. Okay, sine inverse of sine of 11 pi over 9, which is part B of this example. So if I just said, great, well, what's sine of 11 pi over 9? And I go, I don't know. It's not one of my unit circle angles, so I can't just find it easily doing something like that. But I can still draw it, and that's going to be important. So what I'm going to do is draw 11 pi over 9. Okay. So where would 11 pi over 9 be? It's a little trickier. Let's see. This would be 9 pi over 9. This would be 18 pi over 9. In between would be, let's see, 4.5 is half of 9. So this would be 13.5 pi over 9. And again, I'm just doing that to what quadrant am I in? Okay, I'm in quadrant 3, and I'm going to nail down this angle. So 11 pi over 9. So something like this. So the initial side is on the positive x-axis. The terminal side is in quadrant 3. And I'm just going to draw it in standard position, 11 pi over 9. Okay, so I have that. So I go, well, where on the unit circle? So sine of 11 pi over 9 is some value, right? And it's actually equal to the y coordinate right there. Okay, so I go, well, where on the unit circle in between -pi/2 and pi/2, right, will the sine value be equal to that of the sine of 11 pi over 9? Okay, so let's write this like this. So what I'm saying is sine of 11 pi over 9 is some value. But then I go, well, wait a minute, what value is that? Well, I know it's the y coordinate at that angle on the unit circle. So it's some value, okay? And so I know what sine inverse does. It takes that value and returns the angle where that occurs in between negative pi over 2 and pi over 2. Okay, so at what angle do I get a sine value that matches this one over here when I'm in between negative pi over 2 and pi over 2? Well, it's just that reflection again. So it's really similar to what we just had. So it's just this angle over here, right? This has the same height, right? And so this is going to be some x value, but still that same y coordinate because they are at the same height. Does that make sense? So you have like this little, they are at the same height there. Okay, well then what angle do I have to go down to get that? Because sine inverse, right, is the answer is really going to be the angle that I have to kind of drop down to find it. Well, this brings in our reference angle. Okay, so what I'm going to do is go to 11 pi over 9 and find my reference angle. And I'm just going to kind of like draw it in. And I can see that the reference angle for 11 pi over 9 shares the terminal side and the negative part of the horizontal axis. And I'm just going to like color it in so you can really see it. So that's the reference angle for 11 pi over 9. And what's its size? Its size is, it's just 2 pi over 9 because I do 9 pi over 9 to get that half rotation, and then 2 more pi over 9 to get down to 11 pi over 9. So that's that size. Well, then the angle on the other side has to match, right, that I just drew in. This angle over here has to be that same size. But to get to it, I need to do my clockwise. So I'm going to have a negative angle, and that negative angle is going to be negative 2 pi over 9. Right? So what this is really saying is sine of 11 pi over 9 is some value. When sine, and I don't know what that is, and I never actually have to find it. When sine inverse comes across that value, it's going to say, where does this sine value occur in my range, right? Where does sine have this output in my range? Well, it has that output where the y coordinate is the same on the unit circle. And that happens over here. And I really then say, okay, if this is just a reflection across, right, this is just a reflection across the unit circle, then how would I find that angle measurement? And I go, well, it really has to go back to reference angles, which is why we talk about that. So we find the reference angle, and we say the size of that reference angle is 2 pi over 9. Then we kind of think about gluing that reference angle here, because I have to kind of, that's really what that opening is the same size as the reference angle, 2 pi over 9. How would I get to that spot on the unit circle, right? If I'm not allowed over here, I'd have to go in the negative direction to go down negative 2 pi over 9.